Okay, so today we're going to look at rotating a figure on a coordinate plane. When you look at rotations, you're just looking at something that is that turns. So rotations turn a figure around a point, and that point is called the center of rotation. The center of rotation that we're going to be looking at is going to be the origin. So our focus is going to be, let me write that here, our focus for this lesson is to rotate around the origin. Okay, so that's our focus, is to rotate around the origin. The images will be the same size and the same shape as the pre-image. What changes is the orientation. And so when we talk about orientation, we're talking about the direction that it faces. Because it's turning, it may appear to face a different direction. So here it talks about how you can rotate a figure by more than 180 degrees. It shows you in this diagram. It shows you how you can rotate counterclockwise by 120, 240, 300, and that the rotation of the entire figure starting at the beginning all the way around is going to be 360 degrees. We're not going to do all of those rotations. The ones that we're going to focus in on are 90 degrees, 180 degrees, and that's it. So you see that these tell you counterclockwise. 180 degrees, because you're rotating whether you go 180 this direction or 180 this direction, it's going to result in the same image. So it doesn't matter if we say clockwise or counterclockwise. But going this direction would be, that would be clockwise, and I want counterclockwise. So counterclockwise is going in the other direction. So counterclockwise is going this direction. Okay. This rotation doesn't really matter. On this one here where it says rotation counterclockwise, this here is the same as 90 degrees clockwise. And so if it says 270 degrees counterclockwise, it's going to give us the same thing as 90 degrees clockwise. And so that's what we'll be using. We'll be using this one here, 90 degrees counterclockwise, 180 degrees, doesn't matter which way, and also 90 degrees clockwise, which is equivalent to 270 degrees counterclockwise. And these are rules that you can memorize if you want. Hopefully you can find some logical way of doing it, because there's so many things that we have to memorize that this might not be one of those. Okay, so for this class we're going to only perform 90 degree rotation counterclockwise, 180 degree rotation, and then this one again is 90 degrees clockwise. Okay, it's the same thing as 270, but I'll refer to it as 90 degrees clockwise. When you look at these, remember that in your quadrants, everything in the first quadrant is a positive and a positive. Everything in the second quadrant is a negative for our x coordinate and a positive for our y coordinate. Everything in our third quadrant, a negative x and a negative y, and in the fourth quadrant, a positive x and a negative y. That's important to remember, because if you know which direction they're rotating, you can figure out the coordinates fairly quickly, and then just make sure that you have the correct signs. Because if you notice, just doing one rotation, it switches these. It switches the x and y, and then just notice what quadrant you're in, and then you can figure out the signs. Same thing over here, 90 degrees going the other direction, switches the x and y, and then you just have to figure out which is positive, which is negative. 180 degree rotation is basically a 90 degree rotation, and then another 90 degree rotation. So let's go ahead and jump in and do some examples together. So looking at this first one, if you want to memorize the rule, going clockwise is going to take every x and every y, and it's going to switch the x and y, and it's going to make whatever the x was before the same, and it's going to make whatever the y was before, and it's going to change that. So, sorry, I said that wrong. you're going to switch these, and then whatever your x was, it's going to switch signs. Okay? So that's this rule up here. But I think if we just do the problem, it'll make more sense to you, and you can figure out the signs as you go along. So let's take a look at this one. So as we look at this problem, we know it says clockwise, and we know a clock goes this direction with our second hand and our hour hand and our minute hand. So that's going to be clockwise. So that means whatever was in this quadrant is now going to be here. And this little piece is now going to be up here somewhere. So let's list the original figure, the pre-image. So Q is at -3, 2. R is at -2, 4. S is at 0, 3. And T is at -3, -1. Okay, so I just got those by looking at those coordinates. And now remember I said when we switch them, the places, let's do Q first, keep that in order. So Q, R, S, and T, these are going to be prime. And whenever we do a 90-degree rotation, the X and Y coordinates switch places. So and I'm going to ignore the sign for now and just have 2, 3, and 4, 2, and 3, 0, and 1, 3. Okay, so when we switch, if I think about these values being over here, and this is positive, positive, then I'm going to have both the X and the Y positive for Q. And so the 2 stayed the same, but the Y switched. So it looks like the coordinates that we have here are going to stay the same. So we're going to have 2, we're going to have 4, we're going to have 3, and we're going to have -1. And then all of these signs are going to be opposite. So that becomes a 3, a 2, a 0 can't be an opposite, and that -3 becomes +3. So we're going to go ahead and graph those. 2, 3 is going to be Q prime. 4, 2 is going to be R prime. 3, 0 is S prime. And -1, 3 is going to be T prime. And we're going to connect those. Q, R, S, T, and then those are connected. That makes sense because if I took my paper and I rotated it 90 degrees, look at these coordinates. If I pretend this is my x-axis, I'm at 3, 0, I'm at 4, 2, at 2, 3, and at -1, 3. And all of those would match these coordinates right here. So sometimes students will just take their paper and rotate it that direction 90 degrees and figure out what those coordinates would be, and then get the answers from there. All right, next one is counterclockwise. Counterclockwise means we're going the other direction. So if I'm going the other direction, this isn't going to end up over here, it's going to end up here in that first quadrant. And we know in that first quadrant, everything is going to be positive, positive. So let's list the coordinates for our pre-image. And our pre-image, B, C, and D. B is at 1, -5. C is at 3, -3. D is at 4, -4. So now when we do our image, we're going to take those coordinates and we're going to switch places. So it's going to be 5, 1, 3, 3, and 4, 4. Now, because I know that I'm going to be in my first quadrant, this is all going to take and move all the way up here. All of these are going to be positive because it's positive, positive. So again, if you wanted to see what it would look like, take your pen, hold it here, and rotate your paper 90 degrees. And you can see the coordinates for B would be 5, 1, 3, 3 for C, and 4, 4 for D, which is exactly what we have here. So let's plot those. At 4, 4 is D prime, at 3, 3 is C prime, and at 5, 1 is B prime. And then we just connect those. And it should look like this figure just rotated. Okay, I have another couple problems on the back side, so let's flip our paper over and take a look at those. Okay, so here it says we're going to rotate these counterclockwise. So counterclockwise means that we're going this direction 90 degrees. So let's graph this real quick, and then we will look at how that looks counterclockwise. So I'm going to graph it very quickly.